All right, here comes section 3.3 on piecewise functions. If you watch the video, he did a little reminder for you about how the graphs shift and how these numbers work. We did that the other day in a worksheet that we did together as well. So this should have been kind of familiar to you at this point, that if you have an x minus 2 in parentheses, it moves it right 2, and the plus 1 at the end moves it up 1. Same thing goes for absolute value. If you have plus 3, that moves it left 3, and up 2, and flipped upside down with the negative sign in front. So that's your deal with that. Piecewise functions, he talked about what are they? They're functions that are in pieces, right? Piecewise functions kind of makes sense. They're different functions represented by different domains. Different functions represented by different domains. So they're chopped up. It's like chopped up functions. And so you're looking at then evaluating was the first thing. We did this also the other day as an introduction into the whole lesson. So he drew the graph of what these things look like. You don't necessarily even need the graph. All you need are these equations. So if you have -1, you've got to decide which one of those equations -1 would fit into. And -1 would be in this middle guy between -2 and 5. And so you end up plugging that into the middle function, and you get a -4. Then you're looking at 5. Well, 5 could be this second equation, or it could be the third equation, but you know it's got to be the last guy because it's got the equal to. So if you're looking at that, you put a 5 into that last function, and you end up with a -3. Inside the absolute value, you get -3. The absolute value of -3 is 3, but you have an additional negative sign on the outside that you need to put in there. So that's where it's -3. And 2.5. If I'm a -2.5, if I'm at a -2.5 in the midst of this guy, let's see, which of those equations would you be into? You can't be in any because this one stops at -2 and this one starts at -3. You see how there's a gap? There's a gap between -2 and -3, and because of that, it's not going to exist. You have no equation to put it into. Okay? So it doesn't exist. And then he went into graphing these things. Now he was pretty quick. We're going to do some of these by hand, and we're going to do some of these on Desmos, because I know I showed you on Desmos the other day how to do it. Now it'd be lovely if you could do everything on Desmos, but not always can you do that. And actually to get to the, remember I said there were some harder problems in the later part of the lesson? To be able to do those harder problems, it's probably good for you to have an idea of how to graph these by hand. So we're going to do some by hand, we're going to do some on Desmos so we can show it both ways. All right, so number 2, he went in and he graphed these things. This is a straight line with a slope of -1 and a y-intercept of -3. But you're only graphing it from -2 and to the left, all the numbers that are less than -2. And then between -2 and 1, you've got it being 4. So 4, you can see it's not included on this end, but it is included. Open circle, closed circle for that guy. And the last one's a straight line too, slope of 2, y-intercept of -5, but it only exists where x is greater than 1. So that's this piece, which by the way, he suggested, and I suggest too, use pencil, because we're going to be drawing these and erasing parts in order to do this. It's easiest to draw it with a pencil rather than with a pen, because you'll see, we're going to be working on erasing parts of the graphs. All right, number 3. Number 3, and again, these were all in the video, so if I'm going kind of fast, you can slow me down if you need me to, but I'm assuming that you might have seen these on the video. So the first one is one of those parabolas, moved left 1 and up 7 and flipped upside down. So all of those things we talked about with the graphs, here it is. That's where the vertex would be. So the vertex would be at -1, +7, and it is an upside down parabola. Also, you're sketching these. If you notice, I may not have the x-intercept over here of this parabola in the right place. It's okay, we're sketching. Okay? We're not looking for specifically how this graph goes. We're just looking for a sketch. And then this one's just a straight line with a slope of -1/3 and a y-intercept of 0. All right, this one goes less than 2, this one goes greater than 4. So there's a gap in the middle. All right, on the flip side. on the flip side, now you're looking at three different functions. One is a parabola, moved left 3 and down 5, but it only goes from -2 and to the left. You have a constant of -1 between -2 and 1. You have an absolute value upside down, right 4 and up 4. So I think it kind of makes a little sense why we spent some time doing those intro worksheets that one day of how these graphs shift, because when you go to graph these things, it's going to be really important. So you get a picture like this. And then these are the ones that get more difficult for kids. Number 5 is where it starts to get more difficult, because here's what the story is now. They give you the picture and you have to come up with the equations. And for whatever reason, this particular direction, when they switch it on you, tends to be difficult for students. Over the years of teaching this tends to be a challenging part. So you can tell the first one's a line, and you can tell it goes from -1 and less than -1, closed circle there, so you know your inequality is x is less than or equal to -1. You know it's a line, so you've got to think about what the y-intercept is and what the slope is, and that's how you're coming up with this equation. There's a couple ways you can do that. One of the ways and I think this is what he did on the video, is he took 2 points that were on there and came up with the slope and then the equation of the line. That would be certainly a way to go. The other way you could go is if you could interpret where the y-intercept is and you know what the slope is, then you can just put it together without doing the algebra of it. So we'll see it a couple different ways when we go to do it. This one obviously is a parabola. It's been moved right 2 and down 3. Right 2, down 3, you can see the equation. And it's where x is greater than 0, open circle, and then it's everything to the right. Again, this tends to be a little bit more challenging. We'll do a couple of those today too. 6 and 7, these were checked to see where it's continuous. And it's continuous at the place that you're looking at is whatever the x value is in the inequality. So you have it -1. So you're going to check and see what the value is at -1 for the first equation and for the second equation. And if they equal each other, then it's continuous. If they're different numbers, then it's not continuous. So for number 6, they both came out to be 4. For number 7, when you plug a 3 in, now it's 3 is the value you're concerned about. When you put 3 into both of these equations, you get different answers out. That means it's discontinuous. It's almost like a jump discontinuity, because it has one y value here and another y value somewhere else. So they're not connected to one another, which would make it continuous. So that was all the video stuff. Questions from that? All right, so let's try some of the problems ourselves. So you need your highlighter. Find mine. All right. Number 10 was the first one that I chose. Now remember, numbers 1 through 8 are those evaluating ones that you had to do from the other day. They should be relatively easy. Number 10. The first thing that I do with these is I split up my graph with my highlighter. So take your highlighter, and you've got to figure out how this graph is going to be split. Did you need a highlighter, Noah?
No.
Are you okay?
Yeah.
Okay. All right, so I'm going to split my graph up. My graph currently goes, what am I at? -5 to +5 is the standard graph that they're giving us. The first split that I have goes from -5 to -3. So if I go to -3 and I split my graph, I'm going to highlight right there, because the first part of this graph goes from -5 to -3. And then the next chunk of the graph goes from -3 to 0. All I'm doing is reading these inequalities, and I'm breaking my graph up by those inequalities, whatever they are. So I'm going -3 to 0 with my next highlight. All right, and then I'm going for my next chunk of my graph. It's an itty bitty one from 0 to 1. And again, I'm highlighting that break. And then I'm going from 2 to 4. Well, 2 to 4 means I have to do one at 2 and one at 4. They're the sections of the graph that are going to be in pieces, the pieces of my graph. And then I'm going to go back and I'm going to graph the pieces. Now I'm looking at the equations. The equations are these things over here. Well, there's no x's, which makes it kind of weird. All right, so think about that for a second.
Do you have a pencil?
I do have a pencil, I think. Maybe all sanitary. Hopefully it has ink.
Thank you.
Get out, make sure it works.
That's good. Thank you.
Okay, so now that you had a second to think, what do these things look like? What is this? What is -4? All right, -4. What do you mean -4? How do you graph that? Anybody got an idea?
Would it be a line at that number?
Yeah, it's just a horizontal line at that number, right? So I've got to watch my open and closed circles, but I know I'm at -4 in that chunk of the graph. Well, that chunk of the graph's over here. 1, 2, 3, 4. Here's -4, and it goes like this across this way. There's -4. And it's closed circles on either end, and I know that because it's got an equal to sign with my inequality up here. So I got closed circles on either side of this guy. Okay, cool. So now you got the idea. Then the next one is going to be -1 between -3 and 0. So go to -1, draw your line, your horizontal line across there, and then toss on your open and closed circles. So it's going to be open circle at -3, and it's going to be a closed circle at 0. And then I got another one at 2. So the next one is at 2 between 0 and 1. So I come up to 2, 1, 2, between 0 and 1. Attach the right closed circle, open circles, closed on the left. I'm sorry, open on the left, closed on the right. And then the next chunk of the graph is at, the value is 5. That's up at the top. But it's between 2 and 4. So you're going to have a gap right here between 1 and 2. There are no points. So I start it up here at 2 with an open circle, and I go to 4 with a closed circle. And that, my friends, is that weird piecewise function. So when they're just numbers without x's with them, it's just horizontal lines at that place. Okay. Next one I want to try is number 12. Number 12. And we're going to try these by hand, and then we'll use Desmos to check ourselves. Again, because we're building towards trying to come up with those equations, so it's good for us to be familiar with how they work. So the first one I see, the first equation first thing I want to do is chunk up my graph, right? Take your highlighter, chunk up your graph. You got -1 going on. So it's everything less than -1. So I'm going to put a line at -1, my highlight. And then the next one goes from -1 to 2. That would be here. And then the rest of it goes where x is greater than 2. Okay, so that's all I need to do to chunk up my graph. And then I'm looking at how to graph these different functions. This one I know absolute value. There's a couple things I know about it. That +2, do you remember which way that moves it? Left. Okay, so got it left 2. I've got an up 1. And I have a flip because of the negative sign in the front. So all of those parts are going to come into play with this. That's where the V is for the absolute value. So let's see where that falls for this. Normally it would be at 0, 0. But I'm going to go left 2, 1, 2. I'm going to go up 1. I'm going to put a dot there. Left 2, up 1. And it's going to be flipped upside down. In other words, that's where the V is going to be now. So it's got to go this way. And I'm going to go this way with it. But watch what happens. Am I really going that far? I made my line too long, right? Because this guy over here has to stop where that chunk of the graph stops. And so I'm going to go back, and this is why the pencil comes in. I'm going to erase that part. I have an erasable pen. They're the best. All right, and I am going to open circle this guy right here. Okay. The next one is just a negative x. Well, that's like having a slope of -1. It's like a y equals mx plus b, but the b is 0. There's nothing there. It's just an x. So you got -1 gives me a slope of -1. So if I'm looking at this thing between -1 and 2, you can even use points. Say I put -1 in here. -1 is a +1. Right? So if I look at this, I've got a +1 at this place. I'm just going to put a little dot because I'm not sure if it's open or closed. If I keep going, if I put a 0 in, 0 is still 0. If I put a 1 in here, that would be a -1. And you can see how this line's going to go. It's going to go like this. Now I'm stopping it at the stopping places or going back and erasing if I go over. They're your choices, right? I have a closed circle at both ends of that. Close that up nice and firm. And there's that piece. And then I'm going to the next one. The next one's just an x. So if I plug in, I can do just a plug in. If I plug in at 2, well, x is 2. So I have a coordinate at 2, 2. Just putting a little dot there. If x is greater than 2, then another number I could pick is 3. 3 would be 3. That would be here. And it really only takes 2 points to make the line, but I can keep going and taking more points. 4 would give me 4, 5 would give me 5. And so this is what this line's going to look like. And it keeps going. I am not including 2. I am open circling that. So when it comes to a test or quiz, it's going to be really significant to make sure that you make it clear whether your circle is open or closed on them. All right, questions on that guy? And again, you're either drawing it bigger than the chunk that you gave it and erasing, or you're just stopping at that place. Okay. I want you to try 14, and I'll try 14, and we'll see if we match. Okay? So chunk it up with your highlighter, and then see if you can draw those pieces. This one comes out kind of cool looking. Did you do these already?
Yeah.
Yeah, I see. I'm sorry.
No, you're good. I always do them first so that if I have any questions.
Yeah, that's awesome. I've got a few of my AB kids do the same thing. They work ahead and then, because it's all posted in there for you to do. So when you get in your math mode.
Yeah, I just do it after the video, so it's all like fresh.
Yeah, good. Very good.
Yeah.
All right, you come into a dilemma. Anybody there yet where you've got an open circle versus a closed circle? If you look at where it is at -3, this guy is open circled, which I have an open circle there for this part. However, this guy at that same location has an equal to. So who wins, the open or closed guy? Right, the closed guy wins. So you're going to close up this circle because in equation number 2, it is actually included. Same thing happens over here at 3, -3. But interestingly enough, the 0 both has inequalities that are not equal to. So right here at the peak, at the tip of this guy, that should be an open circle. I'll give you a minute to make sure you got all those pieces. All right, questions from 14. Okay, here's where the harder ones start. Number 16. I was all about the evens, I think, this time.
Wait, I have a question.
Yeah.
How do you do the 4 x equals 0? Can you
That-
do 2 lines on one side?
That is a great question. The question in the classroom is, what's this saying, this last guy? What the heck is that? X equals 0, and you get a value of 4. That actually is giving you a coordinate, and just a coordinate. It's not giving you an equation for like a line or any of these other things. So all it's saying is that when x is 0, y is 4, and that's this weird dot that's hanging out up above. But that's a great question because the notation of this is different than what you've seen in any of the other problems. So when they tell you what it's equal to, that's just giving you the coordinate for that place. So good question. All right, 16 it is. So now the deal is you have to come up with what the equation is, and this is where it gets hard. It's a little trickier. All right, so I've got 3 sections to my graph. So if I think about how I break these graphs up, right, like I've been doing with my highlighter.
What number are we on?
16.
Okay, thank you.
Yep. So I'm looking at 16, and I got to think about how it's being broken up. So I know I'm going to have equations for this thing. Let's see, we're going to make a big old, how many equations am I going to have? 3. Okay, so here we go. I'm going to have a big old fancy pants bracket thing, and I know I've got 3 equations that are going to be part of this. Equation number 1, check out where my graph is here, is going to be, whatever it is, all of my x values are less than -2. Okay, that's this guy here. If I read it from left to right, going left to right, first equation stops at -2. So it's everything less than, not equal to, open circle, so not equal to. The middle equation goes from -2 to +1. If it's a between statement, you put -2 on the left, put an x in the middle, put a +1 on the right, and then you're using less than or equal to signs. So this one's going to be less than or equal to because of the closed circle. This one's just going to be a less than because of the open circle. So between statements, if it's between 2 numbers, that's the standard notation you want to write for saying, okay, all of my x's are greater than -2, but less than 1. All right, last piece, last part of the graph goes greater than 1 and equal to because it's a closed circle. So one of the tasks that you have is figuring out how the graph is being sectioned off. So that's one thing. That isn't that hard. That's not a big deal. It's the next part that's a little tricky. All right, so this right here is a line. Well, we know all lines have to be in some form of y equals mx plus b. Right? So for equation number 1, which means I need to know what is the y-intercept and I need to know what is the slope. there are a couple of ways you can do this. One way would be to pick 2 points that are on the graph and then do y2 minus y1 over x2 minus x1, find the slope, and then use that to help, and one of the points to help you figure out what the equation of the graph is. We did a problem like that when we were doing those intro things. Is it okay to write for the... Yes. Scotty's question says, is it okay to write 1 is less than or equal to x? Yes. Normally we keep the variable on the left-hand side when we do it, and it's not wrong, Scotty. If you like it on the right, you keep it on the right. But normally in math world, we tend to keep it on the left because then we can use the arrow to decide which way it's going. Where if I had it the other way around, like Scotty's asking, if I have it 1 is less than or equal to x, you might think that you're graphing to the left when you're really graphing to the right. So in the math world, we tend to keep the variable on the left. It is not wrong to keep it on the right if you like it on the right. So whatever way you prefer. All right, so one way, like I said, you can pick 2 points that are on the line. Another way is if the graph is clear enough, you can just in your head think about what's the b. If I were to graph this, where would the y-intercept go? So if I were to keep this going, I'm going to kind of keep it going. I'm going to erase it though. It's going to hit the y-intercept at -3. So you know your b is -3. So I know my b equals -3. Can you tell from the graph what the slope is? Well, let's see. My slope is rise over run. So in this case, it's going down. You can tell, remember from slope, dude?
Yeah.
This is a negative slope. So nice, negative. Okay, here we go. If I look at this, I've got a slope of -1. Okay. My rise and run are 1. Let me erase this extra part that helped me figure out my b and put this together. So here's my equation for the first one. Y, oh, I don't need y. It's f of x already. All I need is -1x, -x, minus 3. Y equals mx plus b. I'm just filling in the m, I'm filling in the b, and there you go, -x minus 3. All right, then I'm going to equation number 2. I'll come over here. Equation number 2, well, what is it? Is it a line? Is it a parabola? Is it an absolute value? Like, you got to kind of think about what equation you're thinking of. This guy obviously is going to be a parabola. All right, so we know we've got a parabola, a quadratic, it's a square. Where's the vertex, right? Where's the vertex? Well, the vertex is up here. So instead of it being down here at the origin, where it starts out, it is up 5. What does that look like? Right? It's going to be an x squared plus 5. So it's my up 5 parabola. But I have an issue. What's my issue? It's down. It's an unhappy parabola, right? He's a sad guy. So sad guys have to have a negative in front of it. So what you're going to do is put a negative. I'm just going to put the negative right there. It's a negative x squared plus 5. Okay, then we're going to go to the last one. Also a parabola. Guy number 3 is also a parabola. And that parabola has a vertex that's here now. Now notice I'm not going to where the closed point is, I'm going to where the vertex is. And the vertex is right here. So I've got to think about how that's shifted from the origin. Well, it's gone right 2 and down 2. So this guy's a right 2 and a down 2. So how does that affect the graph? Right? If it's right or left, it's inside the parabola. I mean inside the parentheses. So inside the parentheses, and it's moving right, it's going to be a minus. We talked about why that's counterintuitive. You think about why, if it's x minus 2, why is that a right move and not a left move? We talked about that the other day. And down 2 is going to be another minus 2 on the outside, right? This guy's right side up, so he's positive. And so that is going to be your equation for this last piece. X minus 2 squared, and then a minus 2 as well. And that was why we did all that introductory stuff on those worksheets before we got into this, because you needed to remember how to graph lines. You needed to recognize how these graphs shift right and left and up and down in order to be able to write these equations. So here's what I want us to do. I want us to go to Desmos, and I want you to plug those three things into Desmos, like I showed you to do the other day, with those fancy pants brackets to section off the graph, and I want to see if we get the same thing. So check yourself out. Did we get it right? I don't know. Let's check. So you're going to Desmos. I'm going to do the same thing here. I'll share my screen as I do it too. So you guys try it and I'll try it. We'll see if we match. You're probably faster than I am, right? All right, I have my screen shared. And I'm looking, and obviously, barring the open and closed circles on it, they don't really show them in Desmos so well. But if you look at the general picture for this one, it looks pretty good. I think we got it right. So there's a really good way, that's a really easy way for you to check yourself with these things.
I'm just saying, sorry.
It's okay, God bless you. It's hard to tell under these masks. I had a child sitting in back near Noah yesterday, and because of the masks, he was asking me questions and I couldn't hear what he was saying. I felt so bad. Okay. Questions on 16 before we try another one? You might want to keep your Desmos up for a minute. I'm going to stop sharing mine for a second here. Go back to this. All right, so 16 we got right. 18's the next one on my list, but I want you to try it. Ooh, see if you can come up with that piecewise function. The challenge of the day. And then the last little bit that we're going to do is going to be pretty easy. So just 18 is the last tricky one. And remember how you write a coordinate. You're going to have one of those weird coordinate things like you did back in number 14. They're showing you a coordinate there, so you got to remember how to write this. This one's going to have 4 pieces. 4 pieces. Anyone running into questions? If you think you've got it, check it on Desmos. See if you got the right stuff. I'm watching the thinking faces of kids in the room. Are we ready to talk yet? No, okay. I'm seeing a no. Still thinking. Okay, no, okay, good. All right. These take a while. These are not easy. I 100% agree with you. And they're probably problems that, like, when I'm talking about it, it's like, oh, that makes sense. But when you try to do it on your own, it's a little trickier, a little harder. Yeah, I agree, Bella. All right, some of the kids here are starting to put them into Desmos to check themselves out. Okay. All right, it looks like the kids here are finishing up, so I think you might be in the same boat. So the first thing that I did was I divided it up. What are my chunks of the graph? So one of them is less than 0, open circle. One of them goes between 0 and 2, 0 included, 2 not. One of them is greater than 2, and one of them is when it equals 2. You've got a coordinate there. So the first thing you've got is dividing up the graph. You have an absolute value. Okay, so equation number 1 has to be your absolute value. And that absolute value happens when the vertex has been shifted left 2 and up 4. See where the V is? So if I'm thinking it's left 2 and up 4, and it's also flipped, how does that affect the graph? So absolute value, left 2 is going to be x plus 2 in your absolute value. Up 4 is a plus 4 at the end, and then flipped over is a negative in the front. So all of those pieces need to be what your equation is going to be. So that's what you're putting up here. You've got negative absolute value of x plus 2 and then a plus 4. Equation number 1. Desmos isn't being your friend today, Bella. Give me a second, and then we can maybe share your screen, and we'll see what's up with yours. Can you share screens from your end? I don't think so, unless I make you. Yeah, the answers are just. These are hard. I'm not kidding you. These make you think. These are serious thinkers. Let's see how you make out with the next one, though. I have this one you can see is a parabola. It's got a curve to it. So this one's going to be a parabola. So equation number 2, I know I've got a parabola. And then the question is, where's the vertex? Well, this one was kind of nice to you. The vertex is actually at 0, 0. So guess what? It's just an x squared. Nothing else exciting about him. He's just an x squared. He's right side up. He's happy. All's well. He's not moved up, down, left, or right. So he's just an x squared. So equation number 2 should be an x squared. And then the next equation is when it's greater than. That's this line that's down here. And see how it's a horizontal line? It's always going to be whatever that number is, and that number is negative 3. So it's negative 3 for the next guy. I don't know that these are written quite directly next to one another, and then x equals 2 is the coordinate. So what's the y coordinate here? If x is 2, y is negative 2. And that should be, and by the way, these can be in any order. If you have a different order to them, that's okay. We just need to have the same inequalities written. Yeah, Lily?
For the last one,
Yeah.
I did the same thing. I actually got that, but I put it in Desmos and it didn't come up.
It didn't come up with the coordinate.
Mm-hmm.
Let's see.
It did that for me too. You have to just put in the coordinate point.
You have to do it as a coordinate rather than as a y equals. So if we go into, the question is coming up that Desmos did not like that coordinate that's in that one. So let me get back. Now I still have these guys in, but say you wanted to put a coordinate in for that last piece where you've got a coordinate that x is 2 and y is negative 2. Desmos would probably prefer it put in this way, 2 comma, and then a negative 2. And it'll put that coordinate on your graph. So it's an input thing with Desmos. It doesn't like it in that function notation type stuff. So if you have an arbitrary coordinate like this one does, just put it into Desmos as if it were a coordinate, and that way it'll show up on the graph where you want it to be. Okay, questions on that guy? They're hard, kids. These are not easy questions, which is what I was saying to you when we started. The beginning stuff isn't so bad, but then as you try to do the equations yourself, that's really challenging. It's a big thinker. You got to be a big thinker for these. All right, here comes the last one that I want to do with you. Number 20. Number 20. You have to tell if the function's continuous or not. So the question is, what number do I care about? What do I care about? Do I care if x is 10? Do I care if x is 25? What number for x am I concerned about? And you can tell that. Go ahead. Yeah.
-1.
Right, because that's what the inequality is about, right? I want to know what's happening at -1. So that's the first thing. What x value am I talking about? What am I concerned about? I'm concerned about -1. It all comes from, like this one you can see is going to be 5. This guy's going to be 2. This guy's going to be 3. It's based off of what x value that you're around there. Okay, so in our case it's -1. They want to know if you're at -1, is this continuous? Well, if it's continuous at -1, then all of these pieces have to be the same answer when I plug a -1 in. So it's direct substitution. I want to know in equation number 1, what do I get if I plug in a -1? So in equation number 1, I'd have -1 plus 3. I get an answer of 2. If I go to equation number 2 and put in a -1, -1 squared minus a -1, probably want to use parentheses amidst all this loveliness. And here's one of those we talked about when we did is -3 squared 9 or -9, right? We talked about that a few times. It's come up. You can see here it is again. But if you use the parentheses, it tends to make this a little bit easier. So -1 squared is 1. I get a 1 plus -1 gives me 2. And I say, woohoo, that's awesome. My two answers are the same. However, I still need to go to number 3. And number 3 says if x is -1, in other words, it's giving me a coordinate. If x is -1, y is 3. And so the question is it continuous? These two things are the same, but this guy is different. All of them, all of the equations at that number have to match to the same answer, the same y value, in order for it to be continuous. So because they're not all 3 the same parts, I have 3 equations. Because all 3 are not the same, that makes this discontinuous. Or tell if the function is continuous, we're saying no. Just say no. That guy is not continuous. Okay. Do you have questions from anything from this lesson? Do you want to try another one of those where you come up with the equations, since we have time? It's one of your problems anyway. Why don't you go back and see if you can do, the uglier one is 17. So take a minute and see if you can do 17, and we'll see if we match. Again, you're going to come up with the equations. This time it's not as specific how it's divided up. You might want to kind of think about that. Like in the other one, it's very easy to see where it's chunked out. But this one, it's going to be at -2 and at +2. So you have 3 different equations going on for this one. See if you can come up with those equations and then toss them in Desmos and see if you get the right picture. All right, my kids here are starting to put it in Desmos. If you're looking at my inequalities that I've got written there, you could have something written slightly different and still be correct. So when we get to talking about the answer, don't panic if you have something a little different than what I do, especially where the less than or equal to's come into play. We'll talk about what possibilities you could have for that. Okay, it looks like my peeps are done here. So the middle part, well, first of all, they're all connected, right? We've got all connections, no open circles. In order for it to pass the vertical line test, it has to be a function, first of all, has to pass the vertical line test, right? So at this location at -2, I can't have two values. I have to have one value for that. And so that's why you have a choice. One of them has to be equal to, and one of them has to be not. And it doesn't matter which one you pick. It just has to be one. Only one can hold the equal to sign at, this should be a -2, at -2. Same thing goes at +2. They're connected, and it can't have two different values because you're a function. So you only have one of those being an open circle and one of them being closed. And again, it doesn't matter which one you choose. It just has to be that one of them is equal and one of them is not. So that's the first thing with my inequalities. The middle guy is just -2, so he's just -2. He's your horizontal line. Life is good. We like those. But the other two are lines. So lines are y equals mx plus b in our minds. If I can figure out what the slope is and what the y-intercept would be, I don't have to pick 2 points and go through the whole thing of figuring out the equation of the line. Let me show you, because that's how I did it on the homework. See over here, I picked 2 points that were over here. I just chose 2 points that went through the line. And then I figured out the slope, I figured out the y-intercept, and put the line together. So yeah, you can do that using your coordinates. But if you can just count to figure out what those things are, it makes it a little bit easier, saves you a little time. I can tell my slope for this line. This is line number 1. The slope is, it's a negative slope, nice. And it is a 2, right? If I were to rise and run, I get a value of 2. So it's a -2. If I go from here to here, the rise is 2, it's over 1. There you go. Now the b's not as easy, because the b goes off the graph on this one. If I were to continue this to figure out where it's going, it would go to here, right? The next point, if I use my slope, down 2. If I use my slope again, down 2 puts me at -6. So my b is actually a -6. And so putting that line together gives me a value of -2x minus 6. If I take equation number 3, that's this guy over here, he has a slope, rise over run, that's positive. 1 over 1 is 1, slope of 1. But what would his b be? BB? I have to continue him on. He would be, here would be the next point, and then this would be the next point, so it would be at -4. So my b would be -4. And so putting that equation together, y equals mx plus b, I end up with a 1x plus minus 4. And they would be the values you've got. Does that feel better? That's the hardest part of the lesson. You just did it right there. Figuring out those equations. Good. Thanks, Bella. Okay, so let me go back to what we're up to for the day. Make sure we fulfilled our obligations here. There were no questions on 1 through 8. We did the notes on 3-3. Due for Monday are the rest of the practice problems. Now, I don't have that put into our Google Classroom page as an assignment yet, but I'm going to do that in the next couple minutes. So I will put that in so that you can turn it in. So numbers 1 through 22 are due by Monday. We have the test coming on Friday. In the meantime, on your radar should be the mastery check, because that's going to be due. So you need to be working on that. And when we're together again on Tuesday, we're going to do the review sheet. Wednesday, we'll go over the review sheet, and then test is Friday. Okay, so that's kind of our game plan for the week, is getting ready for the test. So Tuesday, we'll do a review sheet, and then on Wednesday, we'll go over the answers, and then Friday test. Now, we have still, I don't know, 5 minutes, 6 minutes, whatever. So if you want to stay on, you can, and work on those 1 to 22s. If you want to sign off, have a great weekend, and I will see you again on Tuesday. And that's it. Have a good one, guys.
Pardon the interruption. Just a reminder to please wipe down your desk and